Okay, my next lecture, asymptotic notation. Asymptotic notation, it is a formal language for an algorithm. Asymptotic notations are mainly useful to calculate time complexity of an algorithm. Okay, we have actually three main notations, big O notation, big omega notation, and big theta notation. Okay, in these other two notations are little o notation and little omega notations. These are the actually five types of notations. Okay, first one, big ho notation. Big ho notation. Big ho notation means, okay, big ho notation. It is order of g of n, class of functions, function that grow no faster than the g of n. Theta g of n, class of functions f of n that grow at same rate as g of n. Omega notation means class of functions f of n that grow the at least as fast as g of n. First, what is big O notation? Big O notation is mainly represents uppercase of algorithm, upper bound of an algorithm's runtimes. Upper bound of algorithm's runtime means we can calculate maximum amount of time an algorithm requires for its execution. So it is mainly useful in order to calculate worst case time complexity of an algorithm because we can calculate maximum amount of time an algorithm. So it requires for its execution maximum amount time. So mainly useful in order to calculate worst case time complexity of an algorithm. In this, the definition of an order of omega notation function let f of n less than or equal to c g of n for every n greater than or equal to n naught. What is the meaning of this statement? Definition. A function, let it be f of n comma g of n. F of n comma g of n be two non-negative functions. Actually, f of n and g of n are two non-negative functions when f of n equal to order of g of n. When f of n equal to order of g of n if there exists two positive constants c comma n such that f of n is less than or equal to c of g of n for every n greater than equal to n naught. Okay, in this one in big O notation, this is the graphical representation of big O notation. In this n naught, n means what is n? A number of elements. This is the t, time represents time period. This is the time period. Okay, condition is f of n is less than or equal to c star c into g of n for all n greater than or equal to n naught. Okay, t of n is time period order of g of n. So if n is greater than n is greater than n naught, then we can say that f of n is less than or equal to c of g of n upper bound values. Okay, next omega notation. Omega notation, it is also big omega notation. It is mainly represents lower bound of algorithms runtime. Lower bound of algorithms runtime. What is omega notation? It is a lower bound of omega notation. We can calculate minimum amount of time that an algorithm requires for its execution. So it is mainly useful in order to calculate best case time complexity of an algorithm. Because why best case time complexity? Because minimum amount of time an algorithm requires for its execution. So this is a big omega notation is a best case time complexity of an algorithm. Next, definition. A function t of n is said to be in omega g of n denoted t of n is belongs to omega g of n if t of n is bounded below by some constants. Multiple of g of n for all large n, that is if there exists some positive constant c and some non-negative integer such that What is this meaning of this definition? Let f of n and g of n are two non-negative functions. Then f of n equal to omega g of n. If there exists two positive constants c n naught such that f of n is greater than c of g of n for all n naught n. Next, graphical representation of this omega notation. Omega notation graphical representation T of n, this G of n, these all are the n is a normal time, T is a time period, number of elements. This is big omega notation. This is the lower bound C of G of n time period. These all are the lower bound. Next, theta notation. The theta notation means mainly represent average bound of time that an algorithm requires for runtime. We can calculate average amount of time that an algorithm requires for its execution. So in order to calculate average case time complexity of an algorithm, definition f of n and g of n to be same non-negative functions. So two non-negative functions f of n equal to theta of g of n if the three positive constants C1, C2 and here C1, C2 and T. These all are the three now positive constants and such that C G of n less than or equal to f of n is less than or equal to C2 G of n for all n1 and 2. Okay, it is a graphical representation for big theta notation. Okay, C2g of n is greater than f of n and C1g of n is greater than, less than f of n. So, finally, the statement is big theta notation T of n is belongs to order of g of n. Next, f of n is belongs to order of f of n. The f of n is belongs to order of g of n. This is the not similar with a less than or equal to b. Thank you.